Hi, my name is Justin Pahoni. Welcome to this course on the fast and easy to use framework sweeping the big data world, Apache Spark. Why do we even need a framework for processing big data? We have grep, or some other custom scripting tool for processing our data, right? It's simple and relegated only to the complexity that one machine requires. Well, that might be a problem. How do we deal with the ever-growing data that has become big data? Data that might not even logically fit onto one machine. Or even if it does, the time to process begins to slow down as the size of the data increases. Okay. You say that's the problem MapReduce was built to conquer, parallelizing the processing across a distribution of machines, taking the processing to the data, solving that big data problem by throwing it against big processing power. Okay, sure, this sped up big data's processing by orders of magnitude in comparison to the previously mentioned single machine algorithms. And yeah, this has worked pretty well for a long while, but it has a multitude of difficulties. Algorithm complexities, disk bottlenecks, and not being able to perform more than just batching, to name a few. In comes Spark to the rescue, which uses a number of optimizations that allows it to perform those same Hadoop computations against a fraction of the resources while still running yet another magnitude faster. In fact, at the end of 2014, Spark officially beat the existing on-disk file sorting benchmark, performing 3 times faster than that previous mark, using about 10 times less machines. Taking it one step further, Spark even ran the sort against a petabyte of data and, keeping a constant rate, was able to decimate any previous sorts of that magnitude. And it has continued to dominate the field ever since. But wait, that's not all. Processing time and power are not the only things that Spark shrinks. With Hadoop, big data also means big code, shown by this simple word count example. But big data does not have to mean this clunky beast, as can be seen by this equivalent Spark code. Even within the code itself, the main logic can be discerned in these 4 lines, whereas the MapReduce logic is here, here, and here, muddled throughout the code in between a sea of boilerplate. These reasons by themselves should be enough to persuade you to choose Spark, and we've only just scratched the surface. As we saw, Spark's generalized abstractions result in tinier code, which increases readability, and, along the same vein, those same properties end up allowing for more expressive code. And we've also discussed how Spark has many mechanisms that allow it to speed past its competition. Even our earlier news bulletin was simply computations against disk, whereas Spark made its initial waves as a computation engine that could work off of cached data in memory, taking advantage of the speed that brings, and blow past the competition. We'll see this and other means of Spark's speed throughout the course. Going back to the gains won by a generalized abstraction, testability becomes just about as trivial as any other code you might write. This is because you can write code as if it isn't distributed, only worrying about such things at deployment time. Separation of code from deployment also means that you can now directly interact with your data from your local machine, figuring out your algorithms on the fly in near real time. This allows you to start with your prototype, building it into production code, and scale up and out as your processing requires. This even means that you can debug most problems off of a local sample set, growing the code quickly and seamlessly. And any big data processing worth its salt should have fault tolerance built right into the model, as Spark has done from its conception. Last, but definitely not least, is that Spark unifies different types of big data needs. Whether you're processing batch data or streaming data, pushing it through graphing or machine learning algorithms, the Spark toolbelt has something for you, along with different means to visualize said data. Alright, now that you have a better understanding of why we need Spark, let's take a quick step back to review the course structure. In this first module, we'll continue with the basics of Spark and its rapid rise to be the biggest big data open source project out there. Then, we'll dive into the core framework, creating a solid groundwork for writing your own big data program. We'll follow that with a look into cluster managers and the many ways that Spark can be deployed, which will lead into a proper discussion on how to best maintain a Spark program and deployment. That'll leave you with a solid backing towards your first full-fledged Spark application. At that point, you'll be ready to step into learning about Spark's next level of APIs. The libraries built on top of the core: Spark SQL, Spark Streaming, and MLlib and GraphX. Note that while this will be a good start for the libraries, I highly suggest heading over to this course's natural follow-on, handling fast data with Apache Spark SQL and streaming. As titled, it takes what you learn in this course and expands the SQL and streaming side of Spark, which are now the de facto starting points for a modern Spark application. And to complete the course, we'll learn about a number of problems that often crop up in Spark applications, and how to handle them and even get ahead of them, ending with a glimpse into Spark's brilliant future. With regards to the module you're already in, we'll review how Spark compares with Hadoop, traversing the history that led to Spark becoming such a big data powerhouse. Then we'll review how to get Spark onto your machine and dive into a quick demo of its power using the Hello World of Big Data, counting words. And finally, we'll finish this section by preparing ourselves for the rest of the course and the overarching project that we'll work through.